Okay, so section 4.4, Foundations of Math 10. I asked you to fill out this chart, and so we're going to go through it here real quick. And hopefully you're seeing some patterns here. What we're going to do is we're going to use this to explain, or to begin to explain, how fractional exponents and radicals work. Okay, we've talked about radicals, that is, numbers with a root sign, either a square root or a cubed root or fourth root or whatever, radicals. And now, how do these fractional, that is, exponents that are fractions, how does that fit? So 1 to the power of 1/2, okay, if you do that on your calculator, 1 to the power of bracket, 1 divided by 2, bracket, you should get what? What did you get for this one? 1, okay, very good, that's true. What about 4 to the power of 1/2, what did you get there? 2, right? 9 to the power of 1/2 was 3, and then we had 4 and 5. Okay, that is absolutely correct. So you skip over here to the other column, and 1 to the power of 1/3 was 1. You should have gotten 1. 8 to the power of 1/3, 2. Okay, so I think I did some of this on the calculator here to show you. So 8 to the power of 1 divided by 3 should give you 2. 27 to the 1/3 should give you 3. And yes, this is 4 and this is 5. So I guess what I'm hoping that you're seeing is that there's a connection between this number and this number. 2 and 4. 3 and 9. 4 and 16. 5 and 25. What's the connection there? Okay, they're squares, right? So 2 squared is 4. So guess what? 4 to the power of 1/2 equals 2. That means that we're trying to find the square root. So when you have a power of 1/2, that's the same as a square root. What about over here? 2 and 8, 3 and 27, right? These are cubes, right? 4 cubed is 64. So in order to find the cube root, you can use the power of 1 over 3. All right, so what does this mean? Well, let's take a look at what you learned in grade 9, okay, or earlier. You probably learned this earlier. But when you have two powers that you're multiplying together, when the bases are exactly the same, what you can do is write down the answer, the same base, and then you add the exponents. Okay? So that's an exponent law that you've seen before. So let's take a look, and to prove our point here, let's find out what 4 to the power of 1/2 times 4 to the power of 1/2 would be. Okay? That is going to be 4 to the power of 1/2 plus 1/2, which is 4 to the power of 1, which is 4. So we were saying that, hey, this to the power of 1/2 acts a lot like the square root, right? That's what we figured. So does this make sense? If I take the square root of 4 times the square root of 4, does that equal 4? It does. Yeah, because this actually is 2 times 2. Right? So I guess our idea that the power, or the exponent of 1/2 being the square root, is totally checking out here. Okay? So when you have a number, or anything, to the power of 1/2, what we mean is square root. And we'll summarize that in a second. Let's take a look at this one now. 125 to the power of 1/3. If I multiply this by itself 3 times, what I have is I have this. 125 to the power of 1/3 plus 1/3 plus 1/3. Does that make sense? Okay, we add the exponents if we have the same base. And so what's 1/3 plus 1/3 plus 1/3? That's 1. Okay, 125. Now, does it make sense that if we did this, if this was truly this fractional exponent thing, if this was the cube root of 125, and I multiplied it by itself 3 times, does that make sense that the answer here is 125? Okay? Look at this. When you have a cubed root and you cube it, you're like it's like it balances each other off. It cancels each other out. So you're left with 125. All right? So that is very important. So what we can say here in the black, so x to the power of 1 over n is this. The n is the index of the root. So you need to write this out. This is kind of our major rule here that we've just developed, okay? And we're going to do some examples here. Okay, let's just move this stuff down out of the way. All right, so keeping this in mind, let's take a look at 27 to the 1/3. That's the same as the cubed root of 27, which is 3. 3 times 3 times 3. Right? Okay. What about this one? Negative 64 to the 1/3. Is that okay if we have a negative there? Well, remember, it's a cubed root. So you can have negative numbers. What's the cube root of negative 64? What is that? It's going to be some number times itself 3 times to give us negative 64. That answer is going to be negative 4. Right? So what about this one here? 4 over 9 to the power of 1/2. What does that simplify to? That's the same as the square root of 4 over 9. Now what you have to remember here is that when you have a fraction, okay, boys? Hey, boys? Boys? When you have a fraction, you can rewrite this root as, you can separate them to numerator and denominator. Okay? So what's root 4? That's 2, and the square root of 9 is 3. Okay? So the square root of, or 4 over 9 to the power of 1/2 is 2/3. All right, any questions there? Okay, let's do some more. Okay, let's do some more. So what happens if I do, and I'm going to keep these other ones up here. Okay, this is leading to the next point here in the lesson. So you see how I had cube root of 27. So you know about that. So 27 to the power of 1/3 is 3. So you can simplify what's inside the brackets first and then apply the outside exponent. So this is going to be 9. You see that? Remember your order of operations? If you're wondering what to evaluate first and you have a list of operations, evaluate what's inside the brackets first. That's B. Then move to exponents and division, multiplication, addition, subtraction. So you can evaluate this inside the brackets first, and you'll always be doing this correctly. So 27 to the 1/3 is 3. Squared is 9. Over here, we said that negative 64 to the 1/3 was negative 4. Okay, so that's this. And then I'm going to now do this second part. Whoops. Right? So what's negative 4 squared? Is that positive 16 or negative 16? Yeah, it's positive 16. Okay, very good. Now this was, that was a 1/2. So 4 over 9 to the 1/2 we said was 2/3. So what's 2/3 to the power of 3? Again, with the fractions, some things you want to remember is that if you have an exponent, that applies to the numerator, that's the top part, and it separately applies to the denominator. So this can be written as 2 cubed over 3 cubed. Just like the root sign before, how that distributed really to the top and the bottom separately. Okay, so this is 8 over 27. Okay, and that's simple form there. Okay, questions? You guys getting this? Okay. Now, notice this. I don't know if you guys remember, we have another exponent law that you learned, and that was this. A to the power of m, and then if we take that to the power of n, that's a little different than the first one, that is the same as multiplying the exponents, m times n. If you have a power raised to a power, you multiply exponents. So what that means is, it means this, that this right here is also equal to 27 to the power of 2/3. See that? This is equal to negative 64 to the power of, what's 2 times 1/3? 2/3. This is also equal to, let me see, can't maybe see that. This right here, 4 over 9 to the 1/2 to the power of 3 is equal to 4 over 9 to the power of, what's 3 times 1/2? Well, that's 3 over 2. Okay? So that's how fractional exponents kind of work there too. So what I'm saying is that you might see a question like this, and you'll have to figure out what to do there. The number in the bottom is always the index of the root. So you can always write that like this. That 2 can go out there. Okay? This would be the index of the root, cubed root, negative 64. And then the top number goes out there, and so on. Let's get some practice with that. Okay? So what this means, again, the bottom number in the exponent, the denominator in the fractional exponent, is the index of the root. So this is actually root 49 to the power of 3. Okay? That's what that means. What's the square root of 49? 7. What's 7 cubed? 343. Okay? Now let's just check this before we go too much further, because I can see that some of you maybe aren't believing me. So 49 to the power of, let's say, 3 over 2. Look at that. 343. Now we showed all the steps. Okay? The calculator did all those steps at once, gave you the answer. So you can always check on your calculator. 81 to the power of 2/3. That's cube root of 81 to the power of 2. What's the cube root of 81? That's that one. Is there a cube root of 81? It's not a whole number, is it? Is it a whole number? Okay. So this is not a whole number. It's not going to be a whole number. But what you can do is you can actually find the decimal form of this. So let's just say we'll be okay with the decimal form. So what's the cube root of 81? You might have to do that in your calculator. How do we do that? Oh, 81 to the power of 1 over 3 is 4.326. Okay? Well, let's think about that. 4 cubed is 64. 5 cubed is 125. 81 is in between that. Right? So that makes sense. So 4.326 squared. Let's do that squared. 18.72. That's what I get. Okay, now you could do that all in one step on your calculator for sure, but I'm just showing you how the rules still apply even if it's decimals. Okay, this one here, 121 to the power of 1.5. Now you look at this and you go, oh my goodness, we got a decimal and we have a decimal exponent. We've never seen those before. But 1.5 actually can be written pretty easily as a fraction. You know what fraction that is? What is it? Right. 3 over 2 is 1.5. So you can see this as 3 over 2. And now it becomes really easy. Square root of 1.21 to the power of 3. Is 1.21 a perfect square? Yeah, it is. What's the square root of 1.21? It's 1.1. Okay? Now you may need some help here with your calculator on that one. No problem. You can use your calculator here as long as you're understanding where this is coming from. Okay? So that's the answer then would be 1.331. Okay. Any questions on this so far? We've covered a couple different exponent laws, kind of piece things together a little bit for you. So in your textbook, you'll want to look up. Okay, so here's a few things that we'll outline. So write this down. Some powers and rational exponent laws here. So x to the m over n is equal to this. X to the 1 over n to the power of m, which is also equal to, I'll put it underneath here, the nth root of x all to the power of m. So this is sort of just in general language what we've discovered. There's one other thing now that I'll show you that I didn't want to confuse you before, so I did all the examples the same, but there is actually another way you could see this. So watch this. We could write it like this. X to the m to the power of 1 over n. Okay. That's going to be the same as this, really, isn't it? Because when you multiply, what do you get? You get x to the m over n. Okay? But watch this. If you take the nth root of this whole thing, you know what that means? It means we have this. So these two are equal. Okay? So just write that down. Write that down. And you'll be able to look back on this as you do kind of more and more practice as days go by here and you're learning this chapter. Right now this looks like, wow, I don't see the difference there. That's what's going on. Just write it down. Okay? Look back to your notes frequently. As you're doing this stuff, look back and let it sink in. And I'll do a couple examples here to show you what I mean. Okay? Because this is true. Okay? Very, very true. All right, so let's do an example like this. Okay, let's do the 27 to the power of 2/3 again. Let's do that one. Let's do it both ways. The first way looks like this. I've got cube root of 27 to the power of 2. You see the 2 is on the top, so that one goes out here. The 3 is on the bottom, so that goes in here, the index. So if I solve it this way, cube root of 27 is 3 squared is 9. The only difference here with this other thing is what they're saying is you can also look at it like this. 27 squared to the power of 1/3. That's another way of writing 2/3. And so cube root of 27 squared is okay as well. Now, a lot of times you're going to want to simplify a smaller number underneath the root sign. So you don't want a huge number, like what's 27 squared? I don't even know that off by heart here. What's 27 squared? That is 729. Okay, so the cube root of 729. Guess what that is? It's 9. Okay? So this is part of the beauty of math. You can write the same thing different ways. They look totally different, but they're the same. Now, when I say beauty, of course, I mean like the beauty of math. I mean that like as a math teacher. Okay? I'm not super strange, okay? I don't look at this and say, oh, this is beautiful. In a sense, I do, but I know some of you are laughing at me. I am a bit of a nerd, but I'm not, I'm still a regular guy in a lot of senses. Okay? But this is beautiful. It's beautiful. Okay. Any questions? You guys think you could do some of this stuff here now? Let's see if you can. Let's see. Let's see here. Okay. Let's stick with the 27. Try this one. 27 to the power of 4/3. Okay? So show your work. Show the steps. Show me how you're doing this. Are you going to do the cube root of 27 first? Are you going to do 27 to the power of 4 first? How are you going to evaluate this? You almost don't even need a calculator for this. And don't plug in 27 and just to the power of 4/3. Don't do that. Work it out. You shouldn't need a calculator for this one. Go ahead and give it a try. And when you're done that one, do this one. Okay, so one possible way, cube root 27 to the power of 4. We know the cube root 27 is 3. to the power of 4. Oh boy, what's that? 3 times 3 times 3 is 27. Times 3 again is 81. Very good. Okay, what about this one? 8 to the power of 2/3. Well, cubed root of 8 squared. Could do that. That's going to be 2 squared. That's going to be 4. All right. Okay, I'm going to give you, hopefully you got those answers. Anybody get those answers? Put up your hand. Loud and proud. Okay, nice. All right. All right. See, it's beautiful, isn't it? Beautiful. Okay, do this one for me. This is the last one I'm going to give you. Then I'm going to explain a couple things, and then I'm going to let you go on your assignment. 0.36 to the power of 1.5. If you're understanding this lesson, you should be able to do this without a calculator. No calculators. Do not punch this into your calculator. No calculators.
What?
Yes, I'm serious.
Are you sure about being serious?
I am sure about being serious. I'm serious about being sure about being serious. No calculators. Go ahead and break it down. Okay, let's see how you did here. First thing you want to really notice is 1.5 is 3 over 2. What's the square root? I didn't need to put that 2 there, but what's the square root of 0.36? Whatever that is, we're going to take it to the power of 3. Uh-oh, this is going to be hard. What's the square root of 0.36? 0.06 to the power of 3. What is 6 cubed? Oh, a lot of gasps there. What's 6 cubed? Oh, no. 6 times 6 is 36. What's 36?
It's 0.6, not 0.6.
Boo. You're right. 0.6. I made a mistake. I apologize. 0.6. 0.6 cubed. 6 cubed is what? 6 times 6 is 36. 0. What? 0.216? 0.216? Okay, think about this. Is it 2.16 or 0.216? Think about this. You're taking 0.6 and you're multiplying it by 0.6, so you need just over half of that, right? And then you're doing that again, so that's going to be, let's say 0.6, let's say 0.4. Just over half of that again is 0.25-ish. So yeah, so 0.256 because 6 cubed is 256. Okay? Good. Okay, sorry about the decimal place there. 0.256 to 16. Oh, boy, you guys, I tell you. I need to make some more notes here. How can you tell I just added this question at the very end? Okay. Okay, is that correct now?
Yes.
Okay, I see. I don't mind making some mistakes sometimes because you guys should catch the mistakes. If you catch my mistakes, that means you're paying attention. This is good. Sometimes I do them on purpose. Sometimes I accidentally make mistakes, which accidentally makes me a good teacher.
Does he accidentally make mistakes?
Okay. Any questions?